All right, this is Algebra lesson 6.4, elimination using multiplication. Okay, I showed you guys how to do this at the very end of the last time we met. It's really no different than the others. You can use multiplication anytime you want to, but this is where when things get ugly like this, 5x plus 6y equals negative 8, and 2x plus 3y equals negative 5. Remember, when I say to solve this, what does it mean? What am I looking for when I'm solving this? Because what is this thing here? What is that thing? That's a line. What's this thing? A line. What's the answer? What's the solution to this thing? Where the two lines cross, right? Where they touch, that's the solution, right? No matter what, that's the solution. If they never touch because they're parallel, there's no solution. If they're the exact same line, then there's an infinite number of solutions, right? But where they touch, if there's one solution, where they touch, that's the solution. There's lots of ways of doing this. If I wanted to, could I graph that? If I wanted to, could I graph that? Yes. And then where they cross would be it. If I wanted to, could I solve for y? Well, that's what you do, is solve for y to graph it. If I wanted to, could I substitute? Could I solve for x here, shove everything over there, and then replant that and plug that into this one here? I could plug it in. Yeah. That would not be very conducive, right? Do you agree? Then adding or subtracting these things the way they sit wouldn't do me any good because it wouldn't eliminate anything, right? If I added these guys together, what's 5x plus 2x? 7. 6y plus 3y is 9. Okay, what about subtracting? 5x minus 2x is 3. That's no good. 6 minus 3, no, that's no good. Adding or subtracting wouldn't do me any good, right? So this is the last method by which you can use to solve a system, and that is you're going to use elimination. You can always use this method. You can always use this method that I'm about to show you. It just takes time. It's just a long process. It adds steps. Here's the deal. You want to pick one of these. Now look here. I could choose to do x's. Okay? I could choose to make the x's line up. I'm going to force these equations into being able to add or subtract them. Does that make sense? I'm going to force them to be able to add or subtract them. I could multiply this bottom one by what? By 3. And what would that do? By multiplying it by 3, what would that make? What would that have? What would that do? It would make it so that I could subtract them from each other, and that would eliminate the y's. Do you understand what I'm saying? I could multiply this bottom one by 2. And what that would do is go rainbow, rainbow, rainbow. 4x plus 6y equals negative 10. Agreed? And now, can I add or subtract them now? Yeah, I would subtract them. Why would I subtract them? Because 6y minus 6y, that would eliminate the y's, and now I can go about my business of doing the problem. Make sense? If I wanted to, people, and it would still work, and sometimes this is going to happen, I could multiply the top one by 2 and the bottom one by 5, and what's that going to give me as an x? 10x plus 12y equals negative 16, and this one would be 10x plus 15y equals negative 25. By multiplying the top one by 2 and the bottom one by 5, that gives me my 10x's here, and I could subtract them, right? Rainbow, like this, and subtract them, and it would still work. I've just eliminated the x's here. Does that make sense? Which one would you rather do? You'd rather eliminate the y's because there's only one step that needs to be done. Agreed? Makes sense? Okay. Let's do this one. Let's see if you guys can do it. 5x plus 6y equals negative 8, and 2x plus 3y equals negative 5. Solve that system. Okay, this is what you would do. And I show you this. I've already shown it to you, but you need to look at this and go, okay, oh man, that's a mess. What do I do? Can I use graphing? No, that wouldn't be very good. Can I use substitution? No, not very clean. Can I add or subtract them the way they sit? No, I have to turn one. I have to turn one or both, and I have to make it jive, right? So I'm going to multiply the bottom one by 2. Why by 2? To make it so that these line up, right? So rainbow, rainbow, rainbow. 4x plus 6y equals negative 10. Get rid of that thing now at this point so that you aren't confused by it or rewrite them. Now I'm going to subtract them. Why subtract?
Get rid of the y's.
Right, because if I add them, that's not going to help, right? So remember, this is how I do this. Pay attention, don't forget. It's negative 8 minus negative 10. Negative 8 minus a negative means plus. So that's a plus 2. 6y minus positive 6y is 0. They're gone. 5x minus 4x is just x. Oh, x equals 2. Make sense? Now what do I do with that? X is 2. Plug it into where?
Anywhere.
Either one of them. 5 times 2 plus 6y equals negative 8. 10 plus 6y equals negative 8. Minus 10 minus 10, 6y equals negative 18 divided by 6 divided by 6. Y equals negative 3. Y equals negative 3. You'd write the answer to negative 3. How many of you got 2, negative 3? Does it make sense? Even if you didn't get it, does it make sense? What did you do wrong? Yeah. Remember, you got to multiply both sides, otherwise you're cheating, right? You got a question?
Negative 7, 4 and a half, and I checked it.
No, guaranteed that's not true. Yeah. Let's try it again. Let's do another one. Let's go 9. They're going to go 9r plus q equals 13. Does the r and the q bother you? No. And 3r plus 2q equals negative 4. You have choices here as to what you're going to do. Agreed? Now, I want you to use multiplication, but you could choose 2 ways to do that. So here we go. Here's the deal. What could I have done? There are a couple of options here. What could I have done? What could I have done, Lou? What's one thing I could have done?
Multiply the bottom by 3.
I could have multiplied the bottom by 3, and what would that have done? That would have gotten rid of the r's, the 9 r's, right? I could have done this, multiplied it by 3, and that would have gotten rid of that. I agree. What else could I have done? Could I have multiplied the top by 2? And then what would have that gotten rid of? The q's. It would still work. Remember, by me multiplying this by 3, I'm multiplying both sides by 3. What have I done to this line? What have I done to the line? Nothing. I multiplied both sides by 3. It's still the same line, right? If I multiply the top up here by 2, what have I done to this line? I've done nothing to that line. If I take both equations, if I take both sides and multiply or divide or add or what, I haven't done anything. I'm allowed to do that. Anyway, let's multiply this here by 3. Rainbow, rainbow, rainbow. 9r plus 6q equals negative 12, right? Subtract them. Should I go like this? Should I just put a minus here? Should I just put a minus out there like this? Guys, I don't see enough of you paying attention. Should I put a minus out here like that? Why not? That will be confusing, right? This negative doesn't just have to do with that negative 9, that 9. It has to do with all of it, right? I'm subtracting the whole thing. Put a minus out there. 13 minus a negative 12. What does minus a negative mean? Add. So it is 13 plus 12 is 25. Q minus 6q is negative 5q, right? And then 9 minus 9r minus 9r is 0, gone. Divide by negative 5, divide by negative 5. Q equals negative 5. Why is Q over there on the right? Because Q comes, does Q come before or after R? I don't know. Q comes before, right? So then it should be here. Agreed? Agreed? Okay. And then the next one, to replug that in, if Q is that, then we go 9R plus negative 5 equals 13. 9R minus 5 equals 13 plus 5 plus 5. 9R equals 18. Divide by 9, divide by 9. R equals 2. R is 2. And there's our answer. Make sense? How many of you got that? Okay, good. It's important that you put them in the right order, right? It's important that you put them in the right order. Okay. Let me give you a hard one then. Okay. Yeah, we'll do this. Okay, what about this? 6x plus 2y equals 2, and 4x plus 3y equals 8. All right, here we go. So this is where, again, on the test, I'm going to say solve this, and you got to choose the method you're going to use, right? So then when you look at this, you got to go, wait a second, I can't graph it. I mean, I could, it'd be ugly. Wouldn't be accurate. 2, I can't just substitute. It's not simple, so I got to eliminate. So you go, okay, well, what am I going to add? What am I going to subtract? Can I add or subtract any of this right now and just make it work? No, so then I need to multiply one of them to make it so that it's, so can I multiply one of them to make it work? No, I have to multiply them both to make it work. I got to find the least common multiple of something, right? I could choose to multiply the bottom here. Look here, I'm going to choose to multiply them both. I would choose to multiply the top by 3 and the bottom by 2. That's what I would do. It's just a smaller number. Could you multiply the top by 4 and the bottom by 6? Sure, it would work. But big numbers mean, uglier. Let's multiply the top by 3 and the bottom by 2. Rainbow, 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 and then rainbow, rainbow, rainbow. Okay, let's rewrite it. So it goes 18x plus 6y equals 6. Then the bottom is 8x plus 6y equals 16. Do you agree? That I simply just, okay, now can I add them or subtract them? What am I going to do, add or subtract? Because this right here, you would subtract them from each other. Subtract them. 6 minus 16 is negative 10. 6y minus 6y is 0. 18x minus 8x is 10x. Divide by 10, divide by 10. X equals negative 1. Go plug that into the bottom one, whatever. 4 times negative 1 plus 3y equals 8. Negative 4 plus 3y equals 8 plus 4 plus 4. 3y equals 12, divided by 3, divided by 3, y equals 4. How many of you got negative 1, 4 is your answer? At least I'm showing you how to do it right. Did you follow? Did you follow? One little tiny baby misstep and boom, it's over, right? This is where there's so many things that can go wrong. The other thing that I want to make clear here, this is a common mistake, and that is this. If I have 3x minus 4y equals, 8, and then I have, 5x minus 4y equals negative 2, look at these. Everybody just look up here. Look at these. What am I going to do with these to eliminate them? Am I going to add them or am I going to subtract them? If I added them, it's important. If I added them, that's going to put negative 4y plus, which is negative 4 minus 4, which is negative 8. It doesn't eliminate them. This is a common mistake that when you see this, when you see two numbers that are exactly the same, you got to subtract them. Right? I have negative 4. How do I get rid of that negative 4? I got to subtract that negative 4. Right? I see. Okay. Make sure you understand that that's the case. I think you guys are good enough to do this. I'm going to go ahead and give you your homework now so you can get started. It is page 358, 7 through 18 even. Now, one of them does not come out as whole numbers. One of them. Okay, I'm just going to tell you that one doesn't.